Here we are looking at Sasha's lower leg. On the bottom is the ankle joint and ankle ball. In the middle is the shin bone. On the top is the upper joint, which is the shin twist joint. The studio prefers a joint to control the knee, a joint to control the ankle, and a separate joint to control the shin twist while walking. So this shin twist joint is a solution for that problem. Early versions of this joint have a design flaw. They're too weak in one spot. I need to add more material with this 1/8 inch flat bar to strengthen it, to cover up this gap here. The flat bar is in the vise on our mill. I'm doing a spot drill and then a small diameter drill. There's not a lot of wiggle room for mistakes on this, so I'm just really taking my time. Did a small drill, here's a medium drill. I'll even hit it with an even larger drill here in a little bit. Just really no room for mistakes. There's just not a lot of material left after this. Did all that drilling to get ready for this milling operation. It's a half round mill. The bowl shape that this is making is not a bearing surface. It's just to remove material while leaving as much material as I can. I know what I want the shape to look like when I'm done, but I don't know how far down to drill it, so I'm just doing it little bits at a time until it looks the way I want it to look, so that it should work the way I want it to work. And I'm just feeling it. I take a little metal stick in there and just kind of feel in there. If I go too far, I'll have to start all over again. But if I don't go far enough, it's not going to work at all. So just taking my time. Okay, here's a test fit. Here is the top joint plate, putting in that little flat bar I just made, dropping in the ball, just making sure it fits right. The bearing surface is the circle of the drilled hole on the top plate. On this particular joint, I'm not using that bowl shape to control the ball. Okay, we're getting ready to braze these parts together using silver solder, 56% silver solder. The top plate, I'm putting on some flux. Flux is powder mixed with water. The water will melt off, or the water will evaporate out. Doing this on a fire brick. It's hard to hold the parts. Whatever you're using to hold the parts, I'm going to set on fire with the torch. So I either put it in my vise that can withstand the heat or put it on this fire brick. Using MAP gas at 3700 degrees. Here in a little bit I get too anxious. I apply the solder too soon, and it just balls up in a little ball right there. It's not participating at all. I had intended to do this side and then let it cool off and then turn it over and do the other side. But I was surprised to see how far the solder, the braze, had penetrated. So I just heated it back up again and let it finish its thing. If you look closely, you can see the gold color of the copper that's in that silver braze, and you can see it just went everywhere. Okay, here's that part's cooled off. I am just shocked at how far that solder went. It's up on that bowl surface. It penetrated on the other side. I traveled everywhere. I was just shocked at how far it went. But it's a good bond. Here's that same part after a few minutes on the stone wheel and the wire brush. Just cleaned off the fire scale, cleaned up the excess material. Looks all shiny and new. Here's that part, just test fitting, putting a test ball in there, putting another plate on it. The ball is moving the way I want it to move, but the way I created this, if I try to put the actual shin bone in there, then it gets hung up on that little lip of metal on that one side. So need to cut that out of there. I could try to poke it with a stick, and that's not going to get it. I need to cut it out. Putting this part in the vise. Try to Dremel with a wire brush to clean out that excess braze. It didn't really do anything. Tried this sharper tool in there. That helped out. That's not a bearing surface, so it's not really critical that it be clean, but we don't want it gross either. Hitting this now with a 1-inch cutoff wheel in the Dremel. Just cutting it off with like a V shape. Making sure there's enough room for the bone rod, the steel that makes up the shin bone. Okay, that should be good to go just as it is. Look at that. Yay. I don't know about you, but that last guy's all like, oh, it should be good to go just as it is. I don't trust it at all. So let's use some lapping compound, and let's just make sure that this thing rotates the way it needs to rotate and that there's no problems associated with that. So we're using this 55-gallon drum of valve grinding compound. You've probably used sandpaper. This is just sand paste. It's like toothpaste. If you look real close, the little balls, little spheres, the little bits of garnet, I think it is, the hard balls in that, are different diameters. So the longer you use this lapping compound, the larger diameter balls grind down first, and then the medium-sized ones, and then the smaller ones. So the longer you use it, the finer the surface finish becomes. In general, this lapping compound is way too aggressive for most of the needs. A little bit of toothpaste is plenty if I need to clean something up. But on this particular one, all I'm going to do is rotate it. You can see the orange wrench down there. I'm tightening that up, going back and forth with my drill, giving that lapping compound an opportunity to clean up all that, all those bearing surfaces in there. Just make sure that it behaves the way we want it to behave. Okay, cleaned off the lapping compound. If you look real close, you can kind of see a beveled edge. It's a little more beveled on one side than the other, which indicates it's a little bit out of alignment. Same to this side, I think, is more even. No, it's a little off as well. But the main thing is that the ball and that shin bone are held properly. So we're going to put a test piece in here. I'm holding the test piece with a pair of vice grips, just as hard as I can hold them with those vice grips. Put a little red indicator mark on it so that I can see how the ball and the rod are behaving as I tighten the Allen screw to hold these top and bottom plates together. So I tighten it up a little bit tight, and it holds it a little bit. If I tighten it a little bit more, it holds it a little bit more. You can kind of see me turning that wrench. If I tighten it past a certain point, then it just holds it like a vise, and you can see the vice grips, the pliers, actually spinning loose. So I think this joint is behaving just the way I want it to behave. So I think it's good to go. Ready to go in the puppet. Spend some time, clean off the other side of that, and we'll be good to go.